Hello, students, subscribers, viewers, and future engineers. Here are three problems on fluid pressure on plane and curved surfaces. So let me continue. The cross-section of a freshwater tank with a slanted bottom is shown. A triangular door, 1.8 meters by 1.2 meters. So this is 1.8. So perpendicular to the screen, it is 1.2 meters. In the bottom of the tank is hinged at A and is open against the pressure of the water by the cable under a tension P as shown. So calculate P. Also compute the moment of the hydrostatic force about AB. So we have to locate center of pressure both along the plane of the gate and horizontally. So remember the principle. So F acts and passes through the center of pressure. Distance from center of pressure to the centroid of the gate is E, and the centroid of the gate, which is triangular, is 1/3 of 1.8, because this is 1.8 meters. 1/3 of 1.8 is 0.6 meter. So if this is 0.6, we have a right triangle here. This vertical distance is equal to 0.6 hypotenuse sine of 30, and that is 0.3 meter. So that barred H is distance from water surface to that centroid is equal to 1.2 meter plus 0.3, so 1.5 meters. So summation of moment about AA prime is equal to, so we have P, this moment arm is 1.8 cosine 30 because that's 30 degrees, and this is 1.8. So the horizontal projection is 1.8 cosine 30. Then equals F, and the moment arm of F would be E plus 0.6 as shown. So F is equal to gamma barred H area. Specific weight of water 9.81. Barred H is 1.5, already calculated here. And the area is the area of the gate, which is 1/2 of 1.8 or 1.2 times 1.8. So solving for F, it is 15.892 kilonewtons. Then we solve for A, I sub CG sine theta over area barred H, which is BH of triangle cube over 36 sine theta over area of triangle 1/2 BH of triangle times barred H. So simplifying, that would be H of triangle square sine theta over 18 barred H. The height of the triangle is 1.8 because this is the axis through the centroid, supposedly. So 1.8 square sine of 30 degrees over 18 times barred H, which is 1.5, so it is 0.06 meter. So substitute into this equation here, P times 1.8 cosine 30 degrees equals F 15.892 times E 0.06 plus 0.6. So solving for PP is 6.729 kilonewtons. Then to locate the center of pressure horizontally, by principle, we denoted this with L, and this is 0.6, that 0.6 there, and E is 0.06, that one, 0.06, which is now this. Therefore, this distance is 1.8 meters minus 0.6 minus 0.06, so 1.14 meters. So from the figure, by similar triangles, L as to 1.14 equals 1.2 as to 1.8. Solving for L, it is 0.76 meter. So therefore, F acts here, and by principle, this distance from axis AB is half of L, L over 2. So the moment arm of F is L over 2 from this axis here, which is AB. So moment AB therefore is F 15.892 times L over 2.76 over 2. So it is 6.039 kilonewton meter. Then for the next problem, the gate AB shown below is hinged at A and kept closed by a force P at B, which is here. Determine the nearest value of number 1, the total pressure exerted by the oil of the gate. This total pressure, the other term for F, the hydrostatic force. So simply F, that hydrostatic force that this is 7 meters. Then the location of this total pressure from A, and from the figure it is just E, which is E sub V because the plane surface is vertical, then plus 3, where 3 is half of 6. Because this is a rectangle, the centroid is half of the height. So 3, then plus E. So therefore, we call that HA. So HA is 3 plus E. So the answer is 3 point something. So since we have a complicated situation, the surface is under pressure. So the pressure at the centroid is equal to 18. Then we go down by 4 meters because that's 1 meter and this is 3 meters. So this is 4 meters. So the pressure at the centroid is equal to 18, then plus specific weight of oil 0.8 times 9.81 times 4. The pressure at the centroid is 49.392 kilopascals. So we use the formula for F, which is just pressure at centroid times area. The area is 2 by 6, so 12 square meters. So pressure at centroid 49.392, area 12, so F is 592.7 kilonewtons. So that's the answer to 3.1. The location of this total pressure from A, so we solve for E, which is equal to E sub V, and before that, we need to solve for barred H. Barred H is not 4 meters because this is subjected to this pressure here. So we compute, after computing the pressure at the centroid, we equate it to specific weight of liquid in contact with the gate, which is oil, times barred H. So pressure equals specific weight of oil times barred H. So 49.392 kilopascals equals specific weight of oil 0.8 times 9.81 times barred H. So barred H is 6.2936 meters. E equals E sub V is I sub CG. Sine theta is 1 because theta is 90 degrees. So it's no longer appearing in the formula over area barred H. So it reduces to HR square over 12 barred H. So area of rectangle is base times height of rectangle, then times barred H. That's why it reduces to this. So barred H is 6.2936. So we get 0.4767 meters. HAF, therefore, by the way, this is HAF, is equal to 3 plus E, 0.4767, so 3.477 meters to 4 significant figures. Then finally, recompute part 3.1 if the pressure at the oil surface is negative 18. So F prime equals pressure at centroid times area. The pressure at the centroid this time is negative 18 because this is negative 18 plus specific weight of oil times 4 meters. So we still have 4 meters there. So area is 12 square meters. So F prime is 160.7 kilonewtons in the second part. Then lastly, determine the horizontal and vertical components of hydrostatic forces acting on the 3.6 meter wide curved gate shown. The curve is circular. Also locate the components analytically and show that the sum of the moments of these components about O, which is the center of this circular arc, is 0. So by principle, it should be 0 because the moment of F passes through there. But we have to locate FH. We can easily locate FH because the surface is flush with A, and this is rectangular area, projected area, which is 6 sine, the height is 6 sine 40, 6 meters sine of 40, which is now this one, and perpendicular to the board 3.6 meters wide. And this is the area here. And this side projected surface is rectangular, 3.6 by 6 sine 40. So FH therefore is acting 1/3 because the pressure diagram is triangular, 0 to pressure at the bottom, 9.81 times quantity 6 sine 40. So that is 1/3 of 6 sine 40 degrees, so it is 1.286 meters. So this is one of the answers. The location of FH is 1.286 meters from the bottom. While the location of FB, we have to analyze that analytically first. So this area, this shaded area, in order to solve for FD, because FD is specific weight of water times volume, and volume is this area here, times width perpendicular to the screen, which is 3.6. So we need this area. If we analyze this area, that area is area of trapezoid. Can you see it? That trapezoid there. That one. Then minus area of sector. The area of the sector is 1/2 r square, radius square, times central angle, which is in this case, I denoted 2 theta, because in the location of the centroid, this is the axis of symmetry for this sector, and theta is only half of the total central angle. So 20 degrees, theta is 20 degrees. That's also 20 degrees there. And the distance from O to the centroid of the sector is, I denoted it here with XS, which is along the axis of symmetry, XS. And XS, if you can recall from your calculus, is 2r sine theta over 3 theta. So you can check that by setting theta equals 90 so that it becomes semicircle, and it should result to 4r over 3 pi. But theta here in the denominator should be expressed in radians, so that's pi over 2. And you will get 4r over 3 pi. So that's by checking. If you want more about this, you proceed to statics, and the location of the centroid is in that video there in statics, in my YouTube channel. So, area of trapezoid. So this length, we have a right triangle. So this is 6 meters hypotenuse cosine of 40. And that is 6 cosine 40. And this part, therefore, is equal to 6 meters minus 6 cosine 40. This distance. Horizontal projection of OA is 6 cosine 40. So 6 minus 6 cosine 40, this width here is 1.404 meters. So area is area of trapezoid, 1/2. The upper base is 1.404. The lower base of the trapezoid is 6 meters. And the height is 6 sine of 40. So that's the area of the trapezoid. Then the area of the sector is 1/2 r square. The central angle is denoted by 2 theta, but theta is just half, 20 degrees, half of 40. And it reduces to r squared theta, and theta is 20 degrees, remember. So r squared 6 square and theta 20 degrees converted to radians. So 20 degrees times pi over 180 degrees. So area therefore is 1.711, that area there. So that FV is specific weight times volume, and volume is area times width perpendicular to the screen, 3.6. So specific weight 9.81, volume is area times 3.6. So 60.426, that's FV. FH is gamma barred H area. Gamma is 9.81. Barred H is half of the height, because if you consider this projected area, half of 6 sine 40 is the distance to the centroid of that rectangular projection. So 6 sine 40 over 2, and the area is this area here of the rectangle which is 3.6 meters times height 6 sine of 40. So it is 262.65 kilonewtons. So these are the components of the force. Now for the location, we have located FH 1.286 just for FV. I'll call that X sub V. So we can solve X sub V applying the principle that summation moment about O equals 0. So that's the best way. But since the instruction is analytically, so I'll use this location of centroid of sector and apply Varignon's theorem. So therefore, X sub S is 2R sine of theta. Theta is 20 degrees. All over 3 theta, and theta in the denominator converted to radians. 20 degrees times pi over 180. So we get 3.9193 meters for X sub S. Then we apply Varignon's theorem. Since we have not located the centroid of trapezoid, this trapezoid is broken down into triangle and rectangle because we can easily locate the centroids of the triangle and rectangle. So instead of locating the centroid of trapezoid, we apply Varignon's theorem for that. We just break the trapezoid into triangle and rectangle. So since this is 6 cosine 40, the base of the right triangle, then the location of the centroid from O is 2/3 of 6 cosine 40 degrees, and that's 3.0642 meters. While the location of this rectangular area is 6 meters radius minus half of this width, and that width is 1.404. So 6 minus half of 1.404 is equal to 5.298 meters. So by Varignon's theorem, area, which is 1.711 times XV, is equal to area of triangle times x of triangle plus area of rectangle times x of rectangle. In other words, that's already the sector, that's already the trapezoid times barred x. We just break the trapezoid into triangles and rectangles so that we can easily locate the centroids. Then minus area of sector times x of sector. The x of sector is, since this is XS inclined and we have another right triangle, x of sector is this projected horizontal line or length, and it is equal to XS cosine of 20 degrees, where x sub s is 3.9193 computed here, meters, then cosine of 20 degrees. So that's XS of the sector, x of sector. So area 1.711 times XV. The area of this triangle is 1/2 base, which is 6 cosine 40, times height, which is 6 sine 40. So that's the area of the triangle, and the distance of the centroid of triangle from O is 3.0642 meters, x of triangle. Then plus area of rectangle 1.404 times height 6.6 sine of 40. That's the area of the rectangle. Then the x of rectangle from O is 5.298. Then minus area of sector, which is r squared theta, 6 squared theta 20 degrees pi over 180. That's the area of the sector. Then x of sector is 3.913 cosine of 20, which is this 3.9193 xs cosine of 20. So solving for XV is 5.5906 meters. So there is sense because this total distance is 6, and therefore the location of the centroid of this area here, XV, should be slightly less than 6. So there is sense. So finally, summation of moments about O. Let's check if it is really 0. So let's consider counterclockwise as positive. So we have FH times 1.286 minus FV, because FV is clockwise. So FV times XV. So FH is 262.65 kilonewtons times 1.286 minus 60.426 FV times XV, 5.5906 meters. So it is approximately 0. The value is negative 0.0497, and the reason why there is still a very small value, it's because of rounding of answers. So for instance, if I made this accurate, this 1.4 over, if we add one more value, then it becomes more accurate. But that is practically 0. So that's it for this video. I hope that you were able to follow the explanations and the solutions. The video is long, but this is about 1 hour. Supposedly it extends, and I will no longer present this in the lecture.